When diagnosing misfires, a good place to begin is by checking for diagnostic trouble codes. A P0300 tells us that the misfire has been detected by the PCM, but the cylinder could not be identified. P0301 through P0308 tells us which cylinder the PCM detected the misfire in. If you have a misfire code and it points to a specific cylinder, you can start there, or you can use Mode 6 information to get more information about the misfires. Using the scan tool, select the Mode 6 information screens. If you need more information about Mode 6, go to Mode 6 under Ford Special Test menu. If you know how to use Mode 6 information, continue on. Go through the Mode 6 misfire screens and find the cylinder or cylinders that are misfiring. Here we have cylinder number 6 and it says passed. That means no misfires were detected. Here we have cylinder number 7 and it failed. When you find the cylinder or cylinders that are misfiring, those are the ones you'll want to test. Nowhere on this screen does it tell us why the misfire is present. It could be EGR, ignition, fuel, a mechanical reason. That's the same thing if we had a P0307 for this. It doesn't tell us why the misfire is present, just that it is present, and you'll have to test those systems to find the reason for the misfire. Some more information that is in Mode 6 is this measured value. Now look at it. Above it we have maximum value, 15,526. The measured value is 15,285. That's very close to failing. This may be on a vehicle that where the check engine light comes on, the mill comes on and then goes off, comes on and goes off. It could be failing under certain conditions. So Mode 6 gives you a lot more information about each cylinder. If you go to Mode 6 under the Ford Special Test, we'll show you how to convert these numbers into percentages of misfires. An additional data bit that Ford has is misfire malfunction. If misfire malfunction states yes, that means the PCM has seen misfires and set a fault code. Go look up the code. If the misfire malfunction states no, the PCM has not seen misfires, so there's going to not be any diagnostic trouble codes present. Mass airflows can cause a lean condition. That in itself may cause misfires. The mass airflow may or may not have a code for setting a lean condition. In fact, most dirty mass airflows never set a diagnostic trouble code. So, check the mass airflow against specifications. It's a very important input. In our specifications at the top left there you see key on, engine off, and at idle. Our scan data is at idle, and we're right in the middle of our spec. We have a clean, good mass airflow. The mass airflow sensor is what gets dirty. Looking at the mass airflow voltage will help verify what you see in scan data. Here our lab scope is tracing the mass airflow voltage. On the left there you see where we snap the throttle open, and we expect to see mass airflow voltage go above 3.7. This one went to 4 volts or just over 4 volts. So this mass airflow is not dirty. This element that we're showing you here is not dirty on this vehicle. But a dirty mass airflow element will keep the voltage from going high enough. If the voltage doesn't go to 3.7 or higher, clean it, this element, or replace the mass airflow. Injector pulse width must be normal at idle. On this vehicle, the specs state that at 2.8 milliseconds, the PCM is subtracting fuel. At 4.7 milliseconds, the PCM is adding fuel. What that really tells us is at idle, our injector pulse width should be between 2.9 and 4.6. Use this data with long-term fuel trim and the oxygen sensors to determine rich or lean conditions. Long-term and short-term fuel trims should be less than plus or minus 5, and that's ideally. If you're working on a 100,000-mile engine that has been not well maintained, then use long-term and short-term specifications of plus or minus 10. When injector pulse width is high and long-term field trim is normal, look for the incorrect data causing the PCM to make a wrong decision. We have an injector pulse width that's high and long-term field trim, which is based off the oxygen sensors, it's normal. The PCM is making wrong decisions. Go through every scan data bit and find out which one's wrong. When injector pulse width is low and long-term field trim is normal, do the same thing. Look for incorrect data causing the PCM to make a wrong decision. When injector pulse width is high and long-term field trim is high, go to fuel system testing and vacuum leak testing. Long-term field trim has made a shift to high based off lean oxygen sensors. Was the engine lean because the fuel system wasn't supplying enough fuel, or there's a vacuum leak? EGR can cause misfires. In fact, EGR, the incorrect EGR flow, causes misfires on Fords. It's a very common problem. EGR flow must be within specifications. Our example is 0.9, 9/10 of a volt to 1.1 volt. Compare the flow at engine off to engine idle. Read it and then start the engine up. If the flow increases more than 0.2 of a volt, there's EGR flow at idle, and you're not supposed to have EGR flow at idle. When EGR flow is higher than normal, it indicates that the EGR valve is leaking. It's allowing EGR flow at idle. Study scan data, N mode 6 information, get a direction in which to take your diagnostics.